So today I will discuss about the very famous question, which is rotate an array by k elements. So from the rotate array based questions category, I picked these two questions which are very important. Today I will discuss about the question rotate an array by k elements, and in the next video I will be covering the question how to search an element in a sorted rotated array. So this second question you can give it a try, and today I will discuss about the first question, which is rotate an array by k elements. So what this problem is all about? In this problem, what we need to do, what will be the input will be one array, and you will have one k. K is how many times you want to rotate the array. So for example, whenever k is 2, you will see that 10 and 20 will go in the last. So we are doing the left shift, okay, by k times, and we will get the answer. So this is the question. Now I would say just pause the video and give it a try. How you will solve the problem? What is the first thing which is coming to your mind? And let me tell you one thing, this question so when I went for the Oracle interview, that time they asked me this question. So don't think that this is a very easy question. This is a very good question. If you will explore all the possible solutions, then you will feel that power of the question. So what is the first approach which is coming to my mind is nothing but I will take one temporary array of size k, and we will store the first k elements of the array in that temporary array. Now remaining element will shift by k, and in the last just put the k element. What I mean is, here I will take one temporary array of size 2. Okay, so I will store 10 and 20 in that temporary array. Now just move all the remaining elements, left shift them by k. Okay, so you will see that 30 will come at the first, 40 will come in place of 20, 50 will come in place of 30, and so on. And in the last, just add your temporary array as it is, and you will get the answer. So time complexity of this algorithm will be of n, because we are running one loop, and one extra memory we are using here of size k, because we are storing the first k elements into one temporary array. So the space complexity will be of k. Now this is the good approach actually, but here we are using one extra memory. So the next constraint which will come to your interview will be, hey, can you solve it without using extra memory? Okay, let us give it a try. So the second approach which is coming to my mind is, I need to move all the elements by k times. Okay, so can I run a loop, and in each loop I will just move one element. Okay, what it means, I will just do the left shift by one element. So this way we can achieve the same thing, but here time complexity will be nothing but k multiplied by n, because we are running one loop, k times loop we are running, and for every k times I am doing the left shift of all the array elements by one, right? So the time complexity will be nk. Space is constant because we are not using any extra memory here. Now the next constant which will come to your interview will be, hey, can you solve it in less than this time? And I want that space complexity should also be constant. So there is one very famous algorithm for this problem which is reverse algorithm called. Okay, what this reversal algorithm talks about is, you just need to, there are 3 steps you need to do. Step 1, just reverse the first d elements which you want to. D is nothing but your k. Okay, so first of all, just reverse your first k elements. For example, here k is 2, so just reverse the 10 and 20, you will get 20 and 10. Right, now you need to reverse the next remaining elements. So next remaining elements are nothing but from 30 to 60, reverse them, you will get 60, 50, 40 and 30. Step 3, just reverse the full array. So if you will reverse the step 2 array, you will get 30, 40, 50, 60, 10 and 20, and this is what we were expecting, right? So this way we got the answer, and here time complexity will be, we are just doing the reversal 3 times. So time complexity will be of n, space complexity will be of 1. Time is n and the space is nothing but of 1. So don't you think that this is one of the very good approach? Let us quickly jump to the coding part. I have written the code already. So let me show you the code. Here you can see we have an array, okay? In this array, what we will do, first step will, we need to reverse the first k elements. This particular method we are passing from this index up to this index, you need to reverse the array. Second, remaining elements you need to reverse. Third, you need to reverse all the elements from 0 to the last of the array. So, and for reverse array, very simple algorithm I just added here. You just need to do the swap between start and end until they are, start is less than the end. Okay, and this approach will just do the reverse. If you will run this algorithm, you will see the output is, here k is 3, so we'll get 10, 20, 40, 50, 60, then 10, 20, 30. Now let me just change the k by 2. So what output we should get is 30, 40, 50, 60, 10, 20. All right, yeah, you can see. So this is some very good algorithm actually, but the only problem is if you will not solve it by yourself, if you will not do practice in the interview, this algorithm can click or not. It all depends on how much practice you are doing. All right, so let us discuss the fourth approach, which is very famous approach, is known as the, is based on the juggling algorithm. So what this algorithm is all about is we will move the elements which are at the distance k. Okay, now what I will do, I will explain you with the help of one example, and then we will generate the algorithm from the example only. So let me just quickly jump to the explanation part. So what I'll tell you, okay, let's say we have this array 10, 20, 30, 40, 50 and 60 and k is 2. What output we are expecting is we should get 30, 40, 50, 60 and 10 and 20. You can see this output we want. Okay, now let me do one thing. I will start from the first element. Okay, at the first element I will bring the element which is at distance k. So in place of 10 I will bring 30 here. Okay, step 1, move 30 to the 10. In place of 30, what you need to do, you need to move the element which is at k distance from 30, which is 50. So 50 will come in place of 30. And do this in the cyclic manner unless you will reach to the same point at 10 again. Okay, so in one iteration, you will see that this is the output which we will get. So 30 came here, 50 came here. In place of 50, 10 reached. All right, now we will do the one more iteration. Now this time we will start from the first index. Last time we started with the 0th index, right? So do the same thing. In place of 20, 40 will come. In place of 40, 60 will come. In place of 60, 20 will come. And you will get this. We got the answer, right? This is the juggling algorithm. Nothing but. What we need to do, move the element at distance k towards left side. Now the question which is very important here is, hey, how many times we need to do this kind of iteration? So it is completely mathematics. One simple term you can keep in mind is, it will be nothing but GCD of n and k. Okay, GCD of n and k. If you want the proof of this, how this GCD is coming, I have written the explanation part here. Do not worry about that. So what we are doing here, first of all, sorry. Okay, so what we are doing is we are moving the inner loop in the steps of D, right? Because we are moving the elements at the distance D, right? When we will stop when you reach to the starting point. So that is complete one cycle we are doing, right? One complete cycle we are doing. So I can say that the number of elements in this cycle we need to calculate, and then you need to calculate how many number of such cycles we will get. So if in this explanation you can understand, you can go through it and you will get that the answer number of iteration will be nothing but the GCD of n and d. All right, so you can take the screenshot of these two slides and spend some time. It is very easy to understand. Okay, now let me quickly jump to the coding part. What we will do here is, so here I have written the code just to save our time. So in the first of all, what we need to do, we need to get the GCD, because that will decide how many iteration we want. So GCD of n and k. So for the GCD, this is the algorithm. Okay, if b is 0, just return the a, else just return the GCD of b and a modulus b. You can test it out and you can spend some time on this algorithm. All right, now once we got the GCD, what we need to do, we need to move the elements at the distance k in cyclic manner unless we will reach to the starting point. So this particular condition, this condition will tell us that hey, you reach to the starting point again, right? And this condition will make sure for the cyclic order, if we are crossing the range, it will just keep us in the cycle only. Perfect. And what we are doing, element at the index j plus k, we are moving it to the j, you can see, right? And this we will keep doing, and in the last we will just put the element at the index j here. All right, so you can run it. So for this, when k is 2, we should get the output as 30, 40, 50, 60 and 10, 20. You can see the output we are getting. Now let me just change the k to the 4. Okay, so when k will be 4, what output we will get? We'll get the 50, 60 and then 10, 20, 30, 40. Let us run it. All right, 50, 60, 10, 20, 30, 40. I hope it is clear. Spend some time on this one. Try to write down the code. It is very simple. We are just moving the elements in the cyclic manner, which are at the distance d. How many iteration we want? Iteration will be nothing but the same as the GCD of n and k. I hope it is clear. All right. Thank you, everyone. Please like, share, subscribe. And one thing I just want to add here is, I have seen that few people are disliking the video, which is fine, okay, because no one is perfect in this world. The only thing which I want from you is, when you are disliking, please give me a suggestion why you are disliking. Where do you see the problem? Approach is not clear, or you feel something is not clear, you want some point which I need to improve. Let me know, because we all keep learning by doing only, right? So let me know. I will try to improve on those areas and will try my best to explain you guys data structure algorithm. Thank you everyone.